Welcome to today's discussion on the new hypothesis regarding the possible involvement of ERVs, or endogenous retroviruses, in multiple sclerosis. We have Censi, the first author and driving force behind this theory, here to provide us with a summary. Thank you. I believe this hypothesis offers an interesting perspective as it addresses many unresolved questions. It not only connects what we know about multiple sclerosis, but also recent research on other neurological diseases, providing insights into both the pathogenesis and potential therapeutic approaches using existing drugs. The main idea is that certain viral infections can transactivate or activate viruses that are already present in our DNA. This activation triggers an inflammatory cascade, which, in individuals with a genetic predisposition, can lead to multiple sclerosis or other immune-mediated diseases. This includes rheumatological diseases as well. So, even harmless viral infections or infections that wouldn't typically cause any problems or sequelae can interact with these enemy-within retroviruses that are already inside us. Exactly. And this raises the question of what makes a disease debilitating or any other pathological condition. Why does the endogenous virus or retrovirus become activated and trigger an autoimmune process? There must be other factors at play. Genetic factors vary from person to person, contributing to different susceptibilities to various inflammatory and infectious diseases. For example, the Epstein-Barr virus can cause mononucleosis, cancer, autoimmunity, or be asymptomatic. So, based on this heterogeneous genetic background, which drives the evolution of all living beings, we can potentially intervene by blocking these ERVs with existing drugs, such as antiretrovirals, by targeting this early inflammatory process rather than the immune response itself. Regarding the currently available therapies for multiple sclerosis, it has been observed that they impact the endogenous activity of ERVs. They reduce the activity of ERVs during multiple sclerosis attacks and also the production of anti-ERV antibodies. Additionally, in patients with multiple sclerosis who acquire an HIV infection, the initiation of antiretroviral therapy coincides with clinical improvement. This improvement is even more significant than with traditional multiple sclerosis drugs, as it not only affects the chronic motor form of the disease, but also reduces damage to the brain's white matter, fatigue, and other symptoms. It would be useful to investigate if there are also modifications in ERV-related molecular factors in individuals undergoing antiretroviral therapy. The data on individuals with HIV who are undergoing therapy and have a lower risk of developing multiple sclerosis come from multi-center studies conducted in Europe and North America. On the other hand, the cases of individuals with multiple sclerosis who acquire HIV and start therapy without experiencing clinical improvement are only a few case reports. This is because it is rare to have both conditions simultaneously.